So our next session is 3 contributed talks. Our first speaker is Antonia Saravanu. She's a PhD candidate in computer science at the Department of Computer Science and Telecommunications at the National and Kapodistrian University of Athens, and she'll be talking to us about ranking notable news stories. Antonia, the floor is yours.
Hi, can you see the slides now? Okay, perfect. Hello, everyone. I'm Antonia. My name is Antonia. I'm a PhD student at the University of Athens. And today I will present to you the work I did during my internship at Bloomberg about ranking notable news stories. This work was done with my mentors from Bloomberg's AI group, Giorgio and Edgar, and the full paper was accepted in ECIR 2020. The popularity of news platforms and the increase in citizen journalism have led news to increase in volume and coverage. For example, each day, Bloomberg ingests nearly 2 million articles from 125,000 curated news sources around the globe, in addition to the thousands of articles written by the company's 2,700 reporters and analysts. As a result, readers get overwhelmed by the huge amount of news they have to catch up, and they frequently miss out on news due to heavy filtering. To help readers navigate through the enormous amount of news available today, it is crucial to develop systems that can filter out the noise and adapt to the dynamic information needs of the consumer. In this presentation, we focus on the problem of identifying the notable news from a stream of news stories. To solve the problem, we use structured representation of news stories, and we view the problem as a ranking task. More specifically, we define our task as ranking news representations against notable events. We do so by training learning to rank models on various textual and semantic features. We finally construct a crowdsourcing task to collect the ground truth and validate our approach. Due to the highly condensed language used in news, existing news processing systems generate well-defined structured representations from the content. In this work, we present a news story as an extended triple, which is a subject, a predicate, and an object, together with temporal and location metadata. For example, this news story that you can see in the slide reports on a suicide bomber who killed people by detonating a vehicle full of explosives at a military camp in Gao, Mali. When extracting the structured news representation from this article, we are interested in modeling information about who did what to whom and where and when this happened. The triple is consisted of 2 actors and an action, while the metadata contains information about where and when this action occurred. We use the notation Q to define a notable event composed by a textual description, and we use C to define a candidate news story in a triple format with metadata. Formally, given a query and a stream of candidates, we aim to rank each candidate by its relevance to the query. We use 3 levels of relevance for a pair. The pair is considered as very relevant where all information from the query is included in the candidate triple. It is considered as relevant when some of the information matches. And finally, it is considered as not relevant, if otherwise. Our method works in 3 steps. First, we create meaningful pairs of queries and candidates. And secondly, we extract various textual and semantic features. And finally, we train learning to rank models. In the first step of our method, we create all possible pairs when the query and the candidate satisfy 2 conditions. First, they must have the same publication date, and secondly, they should have at least 1 word in common. We extract 3 types of features. The first type of features take into account the shape of the query or the candidate by, for example, measuring the size of the query. The second type of features use syntactic scores such as TF-IDF and BM25 to evaluate the similarity of the pair. And finally, in the third type of features, we use entity linking to evaluate the semantic similarities of the linked entities mentioned in the query and the candidate. You can find more details about those features in the full paper. We have experimented with a couple of learning to rank approaches, and we show results from RankBoost, LambdaMart, and the Random Forest. We used two independent sources to create our dataset, one for the notable queries and one for the candidate triples. For the queries, we use a list of notable events ordered chronologically and curated by Wikipedia. For the candidate triples, we use a list that contains all kinds of news, notable or not, that might or might not exist in the query source. As described before, we build pairs from those two sources, and the final dataset contains a bit fewer than 10,000 pairs. In order to evaluate our methodology and obtain golden truth, we used a popular crowdsourcing platform and asked annotators to classify each pair of query candidate by its relevance. For this crowdsourcing task, we used the Figure 8 platform. And for each pair, we used majority voting with at least 3 annotators. When the task was completed, the inter-annotator agreement was more than 96%. The final result was highly skewed, with only 4% of the pairs to be labeled as very relevant or relevant, as you can see in the table here as well. As mentioned before, we use RankBoost, LambdaMart, and Random Forest for the ranking task. To show that the entity linking is meaningful, we experiment with using different subsets of the available features. Here we show results from using all the features, from using all features except the entity-related ones, and from using the baseline features. So those are just 2 features, the BM25 and the TF-IDF. We first split our dataset in training, validating, and testing sets. The results of our validations, shown in the figure on the left, shows that with Random Forest, we achieve the best results. The table on the right shows the results on the testing set. We observe that Random Forest is the best performing model for the 3 feature sets. We achieve an improvement of 9 percentage points on mean reciprocal rank score when using all features except the entity-related ones compared to the baseline, and 7 additional percentage points of improvement when we add the entity-related features. Finally, we show some qualitative results of the query with the best and the worst normalized discounted cumulative gain scores. First, we show the query with the best performing score. It is about an attack that caused the death of children in India. The top 1 candidate triple seems to be very relevant to the notable news, as you can see here in the slide. And finally, sorry, oops. Okay. So I'm not sure why. Do you see a black?
Yes, I can see a dark screen.
Well, but you can see this one.
Wow. I can see, thank you.
Wow, just one slide doesn't work.
No worries.
Ugh. Okay. Yeah, I had another slide. Yeah, I had another slide with a worst score. That again, basically, you could see that. Let me try to exit here. Okay.
Yeah.
So, yeah, it's this slide. Do you see this now? Do you see? Okay, perfect.
Yeah.
So in this slide, we show the worst NDCG score that was caused by using this query, which is about a Mexican drug lord that was extradited. And then we saw that the first one ranked triple was about a host visit at the USA by Narendra Modi, which is not a relevant triple. While ranked 9th, you can see a triple that is very relevant. So basically the most relevant triple is ranked 9th instead of 1st. So what we plan to do in the future is add information from external knowledge graphs and basically tag some of the entities to external knowledge graphs in order to have more information. So for example, in the first triple here, you see the name of Narendra Modi. And if we have linked this to an external knowledge graph, we will have the information that Narendra Modi is the current Prime Minister of India. So maybe that triple could be ranked later in the in this list. Okay. So yeah, that was my presentation. Thank you very much. Sorry about the issues at the end. You can find more information if you read the paper, and feel free to contact me with any comments or any ideas you might have on this work. Thank you very much.